Hello viewers, welcome to my channel. In this tutorial we want to start with the introduction into partial fraction and rational function or rational fraction. We understand that fractions are just a symbol used to indicate the division of what? Integers. As in, we have 4/9 is showing a fraction, whereby we have the top to be a function of our numerator, where this is also going to be that of our denominator. Now, if I want to talk about this, I'm talking about rational fraction, which involve what we call polynomial. We know polynomials are just algebraic expressions that have more than two terms. So this is a normal fraction that we have been dealing with. Then under rational, where you have 4x minus 1 over 3x squared plus 9. This is also a fraction because the first is a numerator, the second is a function of what? Denominator. Where there is no common factor between the two, this quotient becomes what we call a rational function. Good. So under partial fraction, what we are going to do is that we are going to decompose or resolve a given fraction to get its partial fractions. So what I mean is that we have dealt with these kind of fractions. This 1 over x minus 1 plus 2 over x plus 2. This is a fraction that we have been doing. That is, we can simplify this. What do? We first of all look out for the LCD, which is a multiple of this. So this is going to be x minus 1 multiplying x plus 2 as our LCD, while this 1 minus x minus 1 cancel itself, remaining x plus 2, because it will multiply 1 to give us the same thing. Then x plus 2 also dividing this, cancelling itself, giving us only x minus 1 multiplying 2. So x minus what? 1. But we can open this to have x plus 2 plus 2x plus what? Minus 2. All over our x minus 1, x plus what? 2. I can see that this is positive 2, negative 2. It will cancel. What will I be having? I'll be having x plus 2x. And that will give us 3x over x minus 1, x plus 2. Now, all that we are going to do is that we are going to do the reverse of what we have done. We have learned under rational fraction, whereby two fractions will be given to you, which you write as a single fraction. So these are what they call partial. This is a partial fraction. This is a resultant what? Fraction. So under this topic, we will be given the resultant fraction and we will decompose that. We will decompose this fraction to get the original. That is our task under this. We already know how to find this into this form. So under this topic, we are going to decompose this or resolve this, not de-resolve, to resolve these particular fractions to form the partial fraction. So don't forget that under rational fractions, we have what they call proper fractions and improper. Under this, if a fraction is proper fraction, it means the degree of the numerator is what? Less than the degree of denominator. I mentioned polynomial. This is a polynomial of a degree 1. Don't forget, since I'm having two brackets, x times x will give us x squared. So it means the degree is 1, the degree is 2. So this is a proper fraction. It becomes improper if I have this. If I have this. This is an improper fraction because the degree of the polynomial here is 3 and the degree is 2. So this is improper. So if you happen to have an improper under this is also a fraction we can decompose. You must first of all do division. Divide the top with this to get a fraction that must not have improper in its expression. Good. Now, if you want to decompose a fraction, there are 4 simple processes that we will be following. Process 1 is where we are going to deal with it. The decomposition is depend on the denominator. So if a denominator is of a factor, a linear factor of ax plus b without repeating, if we have this, the process is that we are going to have a over ax plus b, where a is a constant to be determined. So for the second aspect, we still have a denominator of a linear factor, but in this case is repeated. You know, the n is telling us that whether it is the multiplication. If it is 2, it means the bracket times 2. So to decompose this, we have what we have. Your a will still come over ax plus b, but if the number of the n is 4, it means we'll be having 4 different terms. So the first one plus a2 over ax plus b square, that is power of 1, power of 2, a3 ax plus b power of 3. Then we have your an over ax plus b to the n power. So this is what I'm going to do. It means if this is 4, I'll have 1, 2, 3, 4. If this is 5, 1, 2, 3, 4, 5. So that is the second process. The third process is when the denominator is a quadratic function, as is ax squared plus bx plus c, without any repetition. If that is the case, don't forget this should be irreducible quadratic equation. So I'll be having ax plus b over ax squared bx plus what? C, where a and b are constant to be determined. Good. Then the final one, I mentioned 4 processes, will still be quadratic, but in this case, it is what? Repeated. The process involved is that we can see the procedure we follow there. We are having the same a1x plus b1 over our quadratic function, then plus we get this, then plus it continue that way. So these are the 4 processes that we are going to follow. Our decomposition is based on what? The denominator. The nature of the denominator. We don't consider the numerator. The only time that we consider is when it is improper fraction. By this way, we are having your denominator to be in this form, as in 1 over 3x plus 1. So if you are given this to decompose, it means we are going to write this as a over 3x plus what? 1. Where this a, we said, is a constant to be what? Determined. So that is what we are going to follow. We will solve questions on the first type, then the remaining type will be in the subsequent episode. Okay, so we can see that this, if you multiply, you get a quadratic equation, but since it can be reduced or solved, we leave it this way. So this is still under the first type. So this is going to be, let your 7x minus 25 over your x minus 3, x minus 4 equals to a sitting on the first one here, then plus b sitting on the x minus what? 4. So the first one is a linear. The second one is a linear, so we have this. Now, the equal sign here simply means that whatever expression here is the same as this. So we are going to multiply both sides by equal LCD. That is a common denominator, which will still be this. So if I multiply this side by x minus 3, x minus 4, it will cancel this. So I'll be left with only 7x minus 25. If this is our denominator, it means that it will divide this, cancelling itself, giving us a into bracket x minus 4. I believe if I multiply this expression by this LCD, x minus 4 will cancel itself, give us b multiplying x minus what? 3. So this is what we can get taking care of the fraction to become a linear equation. So we can try to open this bracket to have 7x minus 25 equals to ax minus 4a bx minus 3b. What can we do? I can see x, then constant. So let's do that. 7x minus 25 ax plus bx minus 4a minus 3b. Since I have x, I can bring out what we call common factor. So 7x minus 25 equals to a plus b multiplied by what? X. Then if you want to pick this is also the same. There is no common factor. So we leave it our minus 4a minus what? 3b, or into bracket this way, then we have what? Plus. So now, since we are saying that the left equals to the right, they are polynomial. It means that the terms of equal degree will have the same coefficient. If the left have a power of 3, as in x to the power 3, the x to the power 3 on the right will have the same coefficient. So I'll be comparing the coefficient. By comparing the coefficient, I'll have 7 as the coefficient of x equals to what? A plus what? B, which is the coefficient of x here. That will be our first equation. 25 is also a constant, and all of this also a constant. So negative 25 is the same as what? Negative 4a plus 3b. So what happened here? We can multiply through by negative. So I have 25 equals to 4a plus what? 3b. So we have these two equations here. How do we get our a and b? We can solve this equation simultaneously by multiplying equation 1 by 4 in order to eliminate a. So this is going to be 28 equals to 4a plus 4b, become equation 3. So solving equation 2 and 3 simultaneously, if I subtract 4 minus 4, the a will go. So we're having equation 3 minus equation 2. 28 minus 25. That will give us 3 equals to 4b minus 3b. That will give us only b. So we can put this into equation 1. So put b equals to 3 into equation 1. Then that becomes 7 equals to a plus b, which is now what? 3. So what happened? I am going to maintain the a and send my 3 out. 7 minus 3 equals to a. That simply means that a is equals to what? 4. So our fraction, as we are seeing, this particular fraction. 7x minus 25 over x minus 3 x minus 4 is the same as a, which is what? 4x minus 3, b, which is what? 3 over x minus what? 4. So now we can see this is the partial fraction, this is the resultant fraction. So we have decomposed this fraction to form this form. So it means under rational fraction, this will have been your question. This will have been your question that you will solve in order to arrive at this point. Alright, I believe you have grabbed the concept, even though the video might be a little bit long, but take your time and follow the procedure. Don't forget the next episode will take the second type, which involves the repeating linear factor. Don't miss that. Like, share, and comment. Subscribe if you are new to the channel. Bye-bye.